Welcome back to The Explainer. We're moving beyond theory today and stepping straight into application. If you've been following our journey through the General Emergence Mechanics, or GEM framework, in Series 1 and our earlier explainers, you know we've spent a lot of time on foundational mechanics. Today, we're taking those mechanics and visualizing a beautifully organized, low-friction future of transportation.
So, what if the future of travel isn't just faster, but fundamentally calmer? I want you to think about your daily commute right now. It's probably filled with aggressive driving, blaring noise, that endless stop-start frustration, and just a whole lot of wasted time. It is, by definition, a high-friction experience. Now, imagine a daily commute completely stripped of all that stress, noise, and aggression. What does that actually look like? It starts by contrasting the incredible power of our modern transport systems with their extreme brittleness. Think about it. We move millions of tons of steel around our cities every single day. That's powerful. But it's also plagued by traffic jams, wasted fuel, and massive urban friction. Every rush hour is basically a system teetering on the edge of failure. But what if we replace that brute force approach with entirely proactive, graceful networks? We're looking at a transition from brittle transport to calm, coherent flow.
Section 1. Mobility as coherence systems. To get to that state of flow, we need a really brief reminder of how GEM frames stability. The crucial point here is that a truly advanced mobility system isn't just about moving vehicles from A to B as fast as possible. It is a persistent system. It operates as a dynamical, coherent shell, perfectly designed to absorb the sudden shocks of rush hour, resist cascading into total gridlock, and recover almost instantly when something goes wrong. It maintains its identity as a flowing network, no matter what.
And this brilliantly illustrates exactly how we do that. We can map physical traffic control directly onto GEM's three core axes. Look at how this translates. Depth becomes demand throttling, basically managing the volume of vehicles entering the system so the persistence barrier isn't breached. Stiffness becomes speed harmonization, resisting immediate distortions and those wave effects you see in traffic patterns. And viscosity maps to recovery flush actions, meaning how quickly the network dissipates a jam and returns to a stable state. By engineering these three axes, we can proactively prevent congestion before it even begins. Section 2, reframing the flying car. We really need to completely dismantle those chaotic flying car cliches from 1950s sci-fi, where everyone is just driving in the clouds with the exact same road rage and congestion we suffer from on the ground. Instead of thousands of individual, unpredictable drivers battling for space up there, the real future is a layered, highly intelligent mobility ecology. Quiet, autonomous personal air vehicles are just one small, beautifully coordinated piece of a much larger puzzle. We are talking about an ecology defined by coherence, not chaos. And what makes this quiet future possible is the hard physics of the modal theory framework. Take a look at that peak right at the 255-degree attractor. Driven at 1 terahertz, this coherent shell yields a net sustained thrust of 5 millinewtons, accompanied by those distinct Z3 phase harmonic sidebands in red. What does that mean in human terms? It means we aren't talking about explosive chemical rockets or deafening helicopter rotors. We are looking at a gentle, frictionless hum that gracefully decouples vehicles from the ground. Section 3. Designing for flow. With frictionless movement theoretically possible, we can completely rethink the architecture of the modern city, designing it fundamentally around low-friction flow rather than static gridlock. Let's break down how this ecological layering actually works. First, imagine elegant vehicles gliding effortlessly through organized, dedicated sky corridors, managed by those exact persistence mechanics we just talked about. Second, heavy goods and freight move silently below ground through smart subsurface logistics. And third, because the sky and the underground are doing the heavy lifting, we get adaptive surface networks. We can return the street level back to humans, to pedestrians, and to nature. The city can finally breathe. Section 4, a more graceful life. Now, let's ground this high-level systems theory in reality. How does this physics and network theory actually change your daily human experience? It boils down to this: less noise, less rage, more freedom. By removing the brittle, reactive nature of traffic, that infuriating stop-start frustration that just drains your energy, we actually recover lost time. We drastically reduce the psychological burden of simply getting from point A to point B. It's a complete paradigm shift, from a state of constant friction to a state of profound calm. I absolutely love this concept. Transport that feels more like flow and less like battle. We are ultimately talking about engineering an environment where daily movement is no longer a combative chore.
Instead, it becomes a seamless, natural glide. Imagine arriving at your destination feeling energized and calm, rather than exhausted from an hour-long fight with traffic.
Section 5. Possibilities, not promises.
As we look out at this beautiful horizon, we do have to balance our visionary optimism with some very grounded engineering. These are possibilities, not promises. If these high-level sky transport systems are poorly designed, if they ignore the strict principles of a coherent shell, the sky could easily become incredibly dangerous, visually chaotic, and absurdly loud. We absolutely have to get the implementation right. Because, let's be honest, there are monumental systemic hurdles we have to clear. We are looking at massive challenges in safety, unprecedented levels of coordination, equitable access, energy scaling, and rigorous noise mitigation. A true coherent shell requires flawless systemic coordination to function properly. Without that tight coordination, you risk a cascading failure that quite literally drops right out of the sky.
So, the real takeaway here is a profound shift in perspective. Maybe the future of movement isn't about forcing more and more traffic through broken systems. Maybe it's about designing systems that simply no longer collapse into congestion in the first place. It's about designing elegant persistence networks that do not break.
Which leads us to a thrilling final question. If we can engineer this kind of frictionless flow and deep stability in our terrestrial cities, can we scale this coherence beyond our atmosphere? Join us in the next explainer as we push these possibilities even further outward, applying these exact same principles of flow and stability to orbital habitats and long, slow journeys through the solar system. You won't want to miss it. See you then.